Hey guys, welcome back. In this video we're going to be talking about Newton's law of universal gravity, and this is just described as a formula, which is just F equals to F lowercase g, because that's force of gravity. It's just given by capital G mass 1 times mass 2 over radius squared. And all that means is just big G, as we can call it here, is just a known constant which takes the value of 6.67 times 10 to the negative 11 newtons times meter squared over kilogram square. Alright, and then mass 1 is your Earth or you as a person, and mass 2 is the same thing. Radius is the distance between two objects. Now, notice here what we can also do. Remember from our previous videos that force is just given as ma, right? Acceleration, force of gravity, this acceleration became g. So this mass can now become mass 2 or mass 1. The thing is that it cancels out one of the masses in here, and you end up finding that acceleration in anywhere, any planet, star, galaxy, whatever you want to think about, is given by big G times the mass of that, for example, black hole, planet, whatever, divided by the radius squared. Alright, so now as a really quick example, let's look at the acceleration on the moon given using this formula, and then you can do a quick Google search and compare them. So now what we're going to do is we're going to say, just searching on Google, the mass of the moon is 7.348 times 10 to the 22 kilograms, and then the radius of the moon is 1,737,000 meters. Alright, so now knowing this information, let's plug this into here and find the acceleration, and then we can compare it. Alright, so the acceleration on the moon is 6.67 times 10 to the negative 11 newtons times meter squared over kilogram squared, right? Now multiply times the mass, which we got from a Google search. Most of the time you will be given the mass, and if not, you can calculate the mass using Kepler's law, which we will cover soon in our next videos. Now divided by the radius, which is 1,000 meters, and now don't forget to square this, because if you do, you're going to end up having an awful answer, like I just did in order to prepare for this video. Now please pause this video, put this in your calculator, and make sure you get what we're getting, which is 1.62 meters per second squared. And now if you do a really quick Google search and say gravity or the acceleration on the moon, it's 1.622, and we're pretty close. Now when it comes to unit-wise, so unit-wise, here on top we had newtons times meter squared. What's a newton? What's a force? A way of force, and that's just meters per second squared times kilogram, right? Times a meter squared over kilogram squared. So, and then we multiply it times kilogram, right? And then we divide this whole thing by meter squared. So notice kilogram times kilogram is kilogram squared, so that cancels this right here. Meter squared cancels the meter squares on the bottom, so your final answer units is meters per second squared, which is exactly what we have here. Alright guys, so I hope that was helpful, and here if you wanted to calculate the force exerted on the moon by a certain person weighing, for example, 25 kilograms, right? If a problem says that, now that you know the acceleration, you can just say, okay, F, right, force exerted by the moon is always ma, or the gravity, same thing. And we said that the mass of the person was 25 kilograms, and we know that the acceleration is 1.62 meters per second squared. So now if you just plug this in, you would end up having your force exerted on the moon to a person, which your answer should be 40.5 newtons. Alright, I hope that this video was helpful, guys. Remember, check out our other videos if none of this makes sense. For example, like what is a force and all acceleration. Go back and backtrack. But yeah, check out our other videos, and remember to like us on Facebook and subscribe to YouTube, and check out our website. Thank you. Good luck with studying.